Hello student, welcome to maths class and today we'll do fractions. Our learning objective in this chapters are fractional unit and equal share, fractional unit as the part of whole, measuring using fractional unit, marking fractional length on the number line, mixed fraction, equivalent fraction, simplest form of the fraction and comparative fraction. So all these things we are going to learn in this chapter. We'll start with the introduction. So what is the fraction? Fraction, a part of a whole. That is called a fraction. The fraction is a way to represent the part of the whole or part of a group. For example, if there are 1 pencil out of the box of 3 pencils, that part can be represented by the fraction 1 by 3. So total number of pencils 3. After that we have taken 1, so that will represent 1 by 3, showing 1 part out of 3 equal part. A fraction can represent the part of the whole object, the part of the collection of item. The fraction consists 2 numbers separated by the line. The top number, that is called numerator, and the bottom number, that is called denominator. The number above the line, that is known as numerator, and the number below the line, that is known as denominator. Next is fractional unit and equal shares. So fractional unit. The fractional unit is formed when the whole is divided into equal parts. Each part represents the fraction of the whole. For example, when the pizza sliced into 4 equal parts, so each slice will represent 1 by 4 because the whole pizza is divided into 4 equal parts. So each will represent, here the whole pizza divided into 2 equal parts, then 3 parts, then 4 parts. Each will represent 1 by 4, here 8 parts, so each will represent 1 by 8. Clear? Next is equal share. Equal sharing involves dividing an item and collection so that the person or the part receive an equal portion. This idea is the fundamental of the fraction, as it ensures each part is fair and equivalent. So in fraction we will divide anything into equal parts. For instance, the 2 friends are sharing the apple and they divide into 2 equal halves. So each will receive 1 by 2 of the apple. Equal share helps in the practical situation where fairness and balance is essential. Here we will take some example. 3 guavas together weight 1 kg. If there are roughly of the same size, each guava will roughly weight. So 3 guavas roughly weight 1 kg. So then weight of each guava, total weight divided by 3, 1 by 3 kg. Clear? Next example. The wholesale merchant packed 1 kg rice into 4 packets in equal weight. The weight of each packet, big is 1 kg rice and divided into 4 equal packets. So packet total weight upon number of packet 1 by 4 kg. Clear? Next example. 4 friends ordered 3 glasses of sugarcane juice and shared it equally among themselves. So one drank dash glass of sugarcane. So amount of sugarcane consumed by 4 friends, that is 3 glass. Amount of sugarcane consumed by each, that is 3 by 4. So each drank 3 by 4 glass of sugarcane juice. Example 4. The big fish weight 1 by 2 kg and small one weight 1 by 4 kg. Together they weight. So we'll add them together, 1 by 2 plus 1 by 4. So here we'll take the LCM 4. So 2 plus 1, 3 by 4 kg. Total weight 3 by 4 kg. Next example 5. Arrange the fraction word in order to size from the smallest to biggest in the empty box below. 1 and the half, 3/4, 1 and the quarter, half, quarter, 2 and half. So fraction 1 and half means 1 plus 1 by 2, 1 by 2. 3/4 means 3 by 4. 1 and the quarter means 1 whole plus 1 quarter. 1 plus 1 by 4, 1 by 4. Half means 1 by 2, quarter means 1 by 4. 2 and half means 2 plus 1 by 2, 2 1 by 2. Now we have to arrange the fraction word in order to size from smallest to biggest. So smallest is quarter, then half, then 3/4, then 1 and a quarter, 1 and half, then 2 and half. Clear? That will be the order. Next is fractional unit as the part of a whole. Fraction unit represent the part of something complete or a whole. When we divide the whole into equal part, each section become a fraction unit, illustrating that fractions show how the whole can be broken down into smaller or equal part. Next, we will take fractional unit. When a single item or whole object is divided into equal part, each part is called the fractional unit, that of whole. For example, if a chocolate bar is divided into 8 equal pieces, each piece 1/8 of the chocolate bar. These pieces are equal parts together to make up the entire chocolate bar. Clear? Representing parts of a whole. The whole object, such as a pizza, cake or rectangle, can be divided into half, third, quarter and more. Each piece is a fraction that represents the portion of whole. Half means 1/2, dividing an item into 2 equal parts. 1/3 means dividing at 3 equal parts. Quarter means dividing an item into 4 equal parts. These fractions or the fractional unit add up to recreate the whole. When we put them together, it will make a whole. For instance, 4 quarter add up. If we add 4 quarter, it make a whole. Next example for the fractional unit as the part of whole. Pizza slice. If a pizza cut into 6 equal parts, each part will represent 1/6. All 6 slices together make a whole pizza. Measuring liquid. A liquid of juice, a liter of juice, can be divided into 4 equal parts, each of which 1/4 make a liter. When we add them together, it will make a whole. So each will represent 1/4. Dividing shape. If a square is divided into 9 equal parts, each will represent 1/9 of the whole square. Now we'll take an example here. The figure below show the different fraction unit of the whole chicky. So this is the whole chicky. How much of the whole chicky of is each piece? We have to tell how much of the whole chicky each piece. So in A, this one, we get this piece by breaking the chicky into 12 equal parts. We have to divide it like this. So we have to divide the whole chicky into 12 equal parts. Hence it is 1/2. Total parts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. So we get this piece by breaking the chicky into 12 equal parts. Next, this kind of piece like this. So we get this piece by breaking the chicky into 4 equal parts, hence 1/4. Clear? For that we have to divide the chicky into 4 equal parts like this. Now next, this piece. We get the piece by breaking the chicky into 8 equal parts. For this piece we have to divide the chicky into 8 equal parts. So each will represent 1/8. In D, we get this piece by breaking the chicky into 6 equal parts like this. For that we have to divide the chicky into 6 equal parts. So each will represent 1/6. For E, we'll get this. So for E, we'll get this piece by breaking the chicky into 8 equal half. Hence it is 1/8. For F, we'll get it part by breaking the chicky into 6 equal parts. So each will represent 1/6. For G, we'll get this part by breaking the chicky into 24 equal parts. So each will represent 1/24. We'll get this part in H by breaking the chicky into 24 equal pieces. So each will represent 1/24. Next is measuring using fractional unit. Fractional units are useful for measuring portion are the less than the whole unit, allowing in describe the work with the parts of measuring, or more precisely, in many situations we measure object distance or qualities by dividing them into fraction parts, such as the half, quarter and third. So there we use the fraction. Next is understanding measurement with the fraction unit. Take a strip of paper and imagine it represents 1 unit of length. So we have taken a strip of paper and we have imagined this as a 1 unit of length. Now fold the strip half and unfold, you will see a crease. So you will fold the strip right into middle and open it, you will see a crease. Now that consider the whole strip 1 unit, what is the length of each part? If you fold it, divide in 2 equal parts, so each will represent 1 by 2. If you fold the strip of half again, each half is folded into 2 equal half. So each will represent 1 by 4. Clear? So 2 times of 1 by 4, that is equals to 2 by 4. 3 times of 1 by 4, 3 by 4. 4 times 1 by 4, that is equals to 4 by 4, that is equals to whole, 1 whole. Next is example of using fractional unit in measurement. First, length. The pencil is 7 and 1 by 2 inches long. So we are using the fraction 1 by 2 to indicate the measurement between 7 and 8 inches because we are representing half. Time. A clock can be divided into fraction unit like halves, quarter, for instance. The quarter past, half past, the hour represents 1 by 4 and 1 by 2 for of an hour. Clear? Cooking measurement. Recipes often require fractional measurements such as 1 by 2 spoon of salt, 3 by 4 cup of flour to ensure the accurate proportion. So here in all these situations we are needed fractions. Distance. When measuring distance, fraction units are common. For instance, if someone walked 11 by 2 miles, they have walked 1.5 miles. Now we'll take an example. Example 1. Make using the paper strip. Can you use this to also make? Yes, we can use this 1 by 3 to make 1 by 6. When we divide each part of this 1 by 3 to equal half, so 1 by 3 into 1 by 2 equal half, so it will be equal to 1 by 6 like here. Now example 2. Draw the picture and write the addition statement for the above to show 5 times 1 by 4th of the pizza. 5 times 1 by 4th of the pizza. So represent full pizza and 5 times of 1/4 means 1/4 plus 1/4 plus 1/4 5 times, that equals to 5 by 4. Clear? 1 full and 1/4 pizza. Clear? 9 times 1/4 pizza. 9 times means 2 full and 1/4. So 4 plus 4, 8 and 9. 9 parts. So 1 by 4, 1 by 4 total, 1 by 4, 9 parts. So that is equals to 9 by 4. That is equals to 2 full and 1 by 4. Example 3. Match each fraction unit with the correct picture. So here, total 8 equal part. After that 1 is shaded, that will represent 1 by 8. So in the next one, it is divided into 8 equal part. If we take 2 shaded part, it will represent 2 by 8. Here 3 equal part, 1 is shaded, that will represent 1 by 3. And here you can see 1, 2, 3, 4, 5 equal part. After that 1 is shaded, that will represent 1 by 5. Clear? Next, marking fraction length on the number line. Let us denote a fraction 2 by 9 on the number line. Draw the line segment OA of any length. Divide OA into 9 equal parts. That is the denominator. And take 2 parts out of it to reach the point P. Thus the point P here. So what we have done? We have drawn a number line and divide OA into 9 equal parts. Because here the denominator is 9 equal parts. The second part, that will represent the P. That will represent 2 by 9. Clear? Next example, on the number line in the length 1 by 10, 3 by 10 and 4 by 5. So, draw a line, mark the point O on it. Suppose this is the point O. Now we have to mark 1 by 10, 3 by 10 and 4 by 5. Clear? So, we will divide into 10 equal parts. First part will represent 1 by 10 and third part will represent 3 by 10. Clear? To mark the point A distance from to OA, divide OA into 10 equal part. So 1 by 10, OQ represent 3 by 10. So OR will represent, so OR that is marked 8 by 10. That will represent 4 by 5. Clear? Now next example. Write 5 more fractions of your choice to mark them on the number lines. So you have to mark these fractions. 6 by 10 in the simplest form, 3 by 5. Here you can see the B, that is 2 by 10. OF. Here you can see OF 6 by 10, simplest form 3 by 5. OG, O and G 7 by 10. OB 2 by 10, simplest form 1 by 5. OH 8 by 10, simplest form 4 by 5. OI, O to I 9 by 10. Clear? Next is learning point 7.1. So you have to practice all the questions given here. Next is mixed fraction. A mixed fraction is also known as the mixed number. Combine a whole number and a proper fraction, that makes a mixed fraction. For example, in the mixed fraction 2 1 by 3, 2 is the whole part and 1 by 3, that is the proper fraction part. Mixed fraction represent the amount greater than one whole. To convert mixed fraction into an improper, multiply the whole number by the fraction of denominator, add the numerator and place the result over the original denominator. Next is conversion of the mixed fraction into an improper fraction. Now we will see how can we convert a mixed fraction into improper fraction. To convert the mixed fraction into improper fraction, we will multiply the whole number by the denominator and add the numerator and write the sum as the numerator of the improper fraction and keeping the original denominator. For example, we have to convert 3 2 by 5 into improper fraction. 3 2 by 5 is a mixed fraction. It has whole part and fraction part. So first we will multiply 5 by 3, 15, add 2, 17. So 17 is numerator and 5 is denominator. 17 by 5. Clear? Next is conversion of improper fraction into mixed fraction. Now we are converting improper to mixed fraction. To convert improper fraction into mixed fraction, divide the numerator by the denominator, find the quotient and remainder. The quotient will become our whole part and the remainder will become the numerator of the fraction and the original denominator stay as the same. For example, we have to convert 17 by 5 into mixed fraction. So we will divide 17 by 5. 5 3s are 15. So 3 is our whole part. 17 minus 15, and that is remainder is 2. So 2 will become our numerator and 5 is our original denominator. So 3 2 by 5. Easy tips. Mixed fraction, that is equals to quotient remainder upon denominator. So quotient will become the whole number part, remainder will become our numerator and denominator will become our denominator. Clear? Now we will see some solved examples. Example 1, we have to convert 4 3 by 7 into improper fraction. So for that, 7 4s are 28 plus 3, that is 31, and the denominator is 7. So 31 upon 7. Example 2, we have to convert 29 by 6 into mixed fraction. So for that we will divide 29 by 6. Clear? So 6 4s are 24. So 4 will become our whole part. 29 by minus 24, that will give you 5. So 4 5 by 6. Clear? Example 3, convert 5 2 by 9 into improper fraction. So 5 9s are 45 plus 2 47 upon 9. Now we will take example 7, we have to convert 41 by 8 into mixed fraction. So we will divide 41 by 8, 8 5s are 40. So 5, that will become as quotient, that will become our whole number part. 41 minus 40, that is 1. That will become 1 will become the remainder and that will become the numerator. So 5 1 by 8. Next example, we have to convert 3 5 by 11 into improper fraction. So 11 3s are 33 plus 5, that is 38. 38 upon 11. Clear? Next, learning point 7.2. Practice all the question given in the exercise. Is you have to practice all the question. These questions are for your practice. Next is equivalent fractions. As the name suggests, equivalent fraction means the fraction who has equal value. Now look at the figure given below. This shows 1 by 2, 2 by 4, 3 by 6, 4 by 8, 5 by 10. 10 equal part. After that we have taken 5 shaded part, that will represent 5 by 10. Out of 8 equal part we have taken 4 shaded part, so that will represent 4 by 8. Now we can see the shaded portion of the above figures are equal. 1 by 2, 2 by 4, 3 by 6, 4 by 8 and 5 by 10, they are equal. Such fractions are called equivalent fractions. Note, 1 by 2, here what we are doing? We are multiplying numerator and denominator by the same number. So 2 by 2, then 3 by 3, 4 by 4, 4 by 5. So all fraction will be equivalent fractions. In the fraction, if the numerator and denominator are multiplied by the same non-zero number, the value of the fraction does not change. Similarly, the fraction, if the numerator and denominator are divided by the same non-zero number, the value of the fraction does not change. Thus, the two or more fractions representing the same amount of whole part, that is called the equivalent fraction. Remember, to get the fraction equivalent to the given fraction, we divide the numerator and denominator of the given fraction by the same non-zero number. So to get the equivalent fraction, what we'll do? We'll either multiply or divide the numerator and denominator by the same non-zero number. Next, how to test whether two given fractions are equivalent or not? For that, we'll use cross multiplication method. Let us take two fractions, a by b and c by d. Cross multiply a into d and c into b. If a into d, that is equals to b into c, that means both fractions are equivalent. Clear? So we say a upon b and c upon d are the equivalent fractions, otherwise they are not equivalent. Next, simplest form of the fraction. A fraction is said to be in the lowest or simplest form if the numerator and denominator have no common factor other than 1, then they are said to be in simplest form. Clear? So the word numerator and the denominator both should be co-prime, means there will be no common factor other than 1. To reduce the fraction to its lower term, follow the following step. First, we will find the HCF of numerator and denominator. Now we will divide each term, both the numerator and denominator, by their HCF. So we will get the lowest form. For example, consider the fraction 48 and 60. So their HCF 48 and 60, HCF is 12. So we will divide 48 and 60 both by 12, we will get 4 by 5. That is the simplest form of given fraction. Another method, express the numerator and denominator given fraction as the product of prime factors and then cancel the common factors. Like here, we have done the prime factors, now we have cancelled the common factor. What is left? 4 by 5. That is the simplest form. Now we will take some example here. Example 1. Write 3 fractions equivalent to each of the following fraction. To get the equivalent fraction, what we'll do? We will multiply or divide the numerator or denominator by the same non-zero number. So here we have to find the equivalent fraction of 3 by 5. So first we'll multiply both the numerator and denominator by 2, then 3 and then 4. So we'll get the fraction 6 by 10, 9 by 15, 12 by 20. These are the equivalent fractions. Clear? 5 by 8. So again the same method, we multiply both the numerator and denominator by the same number. Here we are multiplying by first by 2, then 3 and then 4. So we'll get 10 by 16, 15 upon 24, 20 upon 32. All these are equivalent fraction. Clear? Next example. Write a fraction equivalent with the denominator 12. Here our fraction is 2 by 3. We have to make the numerator 12. So for that we have to multiply it by 6. That means that is equal, their value will not change. That means we will multiply denominator with the same number, means 6 into 3. So 12 by 18. Clear? Next example. Write the fractions equivalent to 4 by 7 with the denominator 28. Now we have to make the denominator 28. For that we have to multiply 7 by 4. So that means we will multiply numerator by 4 also. So that is equals to 16 upon 28. Clear? Example 4, show that 4 by 7 and 19 upon 21 are equivalent fraction. For that we will use cross multiplication method. 4 by 7 and 12 by 21. 4 into 21 and 7 into 12. So 4 into 21, that is 84, and 7 into 12, that is 84. Both value is equal, that means they are equivalent fractions. Next example, show that 5 by 12 and 32 by 61 are not equivalent fraction. Again you will use cross multiplication method. 5 into 61, 32 into 12. So the product of 5 and 61, that is equals to 305, and the product of 12 and 32, that is equals to 384. Their value is not equal, that means they are not equivalent fractions. Clear? Next is learning point 7.3. Practice all the questions given in this exercise. Next is comparing fractions. Now we will learn how can we compare the fraction, which one is greater and which one is smaller. Comparing fractions means comparing their values, find out which of the given fractions is greater value and which has the lesser value. To compare the given fraction, the following steps are to be followed. First, we have to reduce the given fractions to like fraction. First, we have to convert. For comparing, we have to convert into like fraction, means their denominator should be same. The fraction with the greater numerator will be greater. Note, if two fractions have the same denominator, the fraction with the greater numerator will be the greater fraction. For example, we have to compare the fraction 2 by 3, 3 by 4, 5 by 12, 9 by 16. So first what we have to do, we have to convert into like fraction by taking the LCM of denominator. So LCM of 3, 4, 12 and 16, that is 48. Now we will convert the given fraction into the equivalent fraction of denominator 48. So 2 by 3, 48 divided by 3 gives you 16. So we will multiply both numerator and denominator by 16. 32 by 48, 36 by 48, 20 by 48, 27 by 48. Clear? Now the next step. Now the denominator are same, so we will compare the numerator. The greatest numerator is this one, 36. Clear? 3 by 4. So 3 by 4 will be the largest fraction. The last numerator is 20. 20 upon 48, 5 by 12, so that will be the smallest fraction. Thus the given fraction in order of their descending value, means decreasing. We have to start from the greatest and move to the smallest. 36 upon 48, 32 upon 48, 27 upon 48, 20 upon 48, or we can say 3 by 4, 2 by 3, 9 by 16 and 5 by 12. Another method, the fraction can also be compared by making the numerator of all fraction the same and then compare the denominator. In this case, the fraction with the smaller denominator will be the bigger. Let us take the same fraction as given in the example in previous column. So we have taken the same example. Here we are making the numerator same. So we will take the LCM of 5, 3, 5 and 9. So their LCM is 90. Now we will make the numerator same. Now numerator are same, so we will compare the denominator. The fraction whose denominator will be greater have the lesser value. Now we have make the numerator same, so we will compare the denominator. So 90 upon 120, that will be the biggest fraction because their denominator is the least, and 90 upon 216, that will be the least fraction. So 90 upon 120, 90 upon 135, 90 upon 160, 90 upon 216. That is the descending order of their value, or we can say 3 by 4, 2 by 3, 9 by 16 and 5 by 12. That is the descending order. Next is learning point 7.4. So practice all the questions given here. Let's know more. Addition and subtraction of fraction. Addition of fraction, that is sum of like fraction equals to sum of their numerator. Addition of unlike fraction, so first we have to convert into like fraction, then we have to add. Clear? Now we will take some example here. Find the sum. 5 by 12, 1 by 12 and 7 by 12. Like fraction denominator is same. So simply we'll add the numerator and find their sum. So 5 plus 1 plus 7 upon 12. 13 by 12. 13 by 12 is an improper fraction, so we'll change into mixed fraction. 1 by 12. Here we have to find the sum of 6 by 7 and 5 by 6. So they are unlike fractions. First we'll convert into like fraction by taking the LCM of denominator. So LCM of 7 and 6, that is 42. So we'll convert into the fraction of equivalent fraction of having the denominator 42. Now we'll add the same way. We'll simply add the numerator and write the common denominator below. So that is equal to 36 plus 35 upon 42. 71 upon 42, again it's an improper fraction, so we'll convert into mixed fraction. 129 upon 42. Another method, LCM of the denominator 7 and 6 is 42. So what we have done here? We have written the LCM here. First fraction 6 by 7, denominator 7, so we'll divide 42 by 7, so we'll get 6. We'll multiply 6 by the numerator, that is 36. Now we'll divide 42 by 6, we'll get 7, so we'll multiply 7 by 5, 35. Add them together and find the answer. Clear? Next example, we have to find the sum of 2 by 5 plus 3 by 15 plus 7 by 10. Again unlike fraction, first we have to make it like fraction. So we'll take the LCM of 5, 15 and 10. So LCM of 5, 15 and 10 is 30. The same step will be followed and we will find the sum. So that is equal to 13 upon 10, 1, 3 by 10. Next we have to find the sum of 3, 1 by 2 plus 1, 2 by 3 plus 2, 1 by 4. So these are mixed fraction. Clear? So what we'll do? First we'll convert into improper fraction. 3 2s are 6 plus 1 7 by 2, 3 1s are 3 plus 2 5 by 3 and that is 9 by 4. Again they are unlike fraction, so first we'll convert into like fraction and same procedure, we'll add the numerator and write the common denominator and find the answer. So here that is equals to 7 5 by 12. Because it was an improper fraction, so we have converted into mixed fraction. Next example, the weight of 3 girls are 12 3 by 4 kg, 15 1 by 5 kg and 17 1 by 2 kg. Find the total weight. So total weight, again these are mixed fraction. First we'll convert the weight into improper fraction. Now we'll take the LCM of 4, 5 and 2, that is 20, and we will add as we have done earlier. So that is equals to 909 upon 20, 45 if 9 by 20 kg. That is the total weight of 3 girls. In example 6, Priyanka bought a pencil for rupees 4 2 by 5, notebook for rupees 7 3 by 10. How much money should she pay to shopkeeper? So cost of pencil 4 2 by 5, that is equals to 22 upon 5. Cost of notebook, that is equals to 73 upon 10. So cost of both article, will add them together, that is equals to 117 upon 10, or we can say 11 7 by 10 rupees. Clear? Next is learning point 7.5. So practice all the questions given in the exercise. These questions are for your practice, so you have to practice all the questions. Next is subtraction fraction. So we have done addition, now we'll do subtraction. So subtraction of fraction, difference of like fraction, that is equals to subtraction of like fraction upon difference of like fraction. So subtraction unlike fraction, so first we'll change into fraction into equivalent like fractions and then we'll subtract. We'll take some example. Find the difference 6 by 7 minus 5 by 6. So first we'll convert into like fraction by taking the LCM. Here LCM is 42, and once we have converted into like fraction, 36 upon 42 and 35 upon 42. Now we will subtract them. Simply we will subtract the numerator and find the difference and write the common denominator below. So 36 minus 35 upon 42, 1 by 42. Another method, same, first we convert to like fraction by taking the LCM. Now we have written the LCM below and So that is equals to 6 into 6 36 and 5 into 7 35. So that is equals to 1 upon 42. Next example, we have to subtract 4 5 by 9 from 7 1 by 6. So we have to be careful from which number we have to subtract which number. Always subtract smaller number from the bigger number. So first we'll convert into improper fraction. 43 by 6 minus 41 by 9. Now first we'll convert into like fraction. We have taken the LCM, that is 18, and answer is 211 by 18. Clear? Next example, subtract 9 by 10 from 5 1 by 5. So 5 1 by 5, that is equals to 26 upon 5. So we'll subtract 9 by 10 from 26 by 5. So 26 by 5 minus 9 by 10, again will take the LCM, that is 10, answer 43 upon 10. Next example, we have to subtract 4 3 by 5 from 9. So we have to subtract 4 3 by 5. 4 3 by 5, that is equals to 5 4s are 20 and 3 23 upon 5 from 9. So 9 minus 23 upon 5. Same procedure will be same. First we'll take the LCM and then subtract. Clear? So answer is 4 2 by 5. Next, simplify 5 by 7 plus 3 by 14 minus 13 by 21. So first, unlike fraction, so we'll convert into like fraction by taking the LCM. LCM is here 42. So that is equals to 30 plus sign. So we'll put the sign here and plus 9 minus 26. So 30 plus 9, that is 39 minus 26 upon 42. That is 13 upon 42. Clear? Next example, simplify 1 5 by 7 minus 2 1 by 6 plus 3 3 by 4. So first again we'll convert into improper fraction like here. Then we'll take the LCM. LCM is here 42 and same way we'll subtract. So that is equals to 39, minus sign is there. So we'll put the minus sign, 52 plus 90. That is equals to 77 upon 24. 3 5 by 24. Clear? Next example. So we have to simplify 3 1 by 3 plus 5 1 by 6 minus 3 3 by 4 plus 4. So again we'll convert all the mixed fraction into improper fraction and the procedure will be same. So one thing we have to keep in mind, we have to check the sign. Where the sign is plus, we have to put the sign of plus, and where the sign is minus, we have to put the sign minus. Clear? So that is equals to 40 plus 62 minus 39 plus 48. So all these are positive number. We'll add them together, 40 plus 62 plus 48, and we'll subtract 39 from it. So that is equals to 37 upon 4, 9 1 by 4. Clear? Next example. Of 5 by 7 and 9 by 14, which is greater and by how much? So we have to compare by cross multiplication. 5 into 14 and 9 into 7. So 5 into 14, that is 70, and 9 into 7 63. Clear? So 70 is greater than 63, that means 5 by 7 will be greater than 9 by 14. Now how much? So we'll find the difference. 5 by 7 minus 9 by 14, that is equals to 1 by 14. So 5 by 7 is greater than 9 by 14 by 1 by 14. Next example, the cost of the notebook is rupees 7 1 by 3, that is pen of 5 1 by 6. Which cost more and by how much? So cost of notebook 7 1 by 3, that is equals to 22 upon 3. Clear? And the cost of pen, that is equals to 31 by 6. So here we have made the denominator same. Here we have multiplied both the numerator and denominator by 2. So 44 upon 6. So that would be easy for us to compare. Now the denominator is same. So we'll compare the numerator. The greater the numerator will be, the greater will be the fraction. So 44 is greater than 31. That means 44 upon 6 is greater than 31 upon 6. That means the cost of notebook is more than cost of pen. Clear? And now we have to find the difference. Same way we can find the difference. That is 13 by 6 or 2 1 by 6. Clear? Next is learning point 7 by 6. So you have to practice all the questions given in this exercise. Practice all the questions given here. Next is summary. A fraction is a way to represent the part of the whole or part of group. A fraction consists two numbers separated by the line. The top number is called the numerator, showing the part we have, and the bottom number is the denominator, showing the total parts in the whole or group. Fraction can also represent the part of group or collection. Here the numerator shows the number of selected item, while the denominator shows the total item in the group. In mathematics, the fraction unit are the part of the whole or the group that represent equal portion. When an item of the collection is divided into fraction unit, each unit is equal to the share of the whole. Equal sharing involves dividing the item or the collection so that each person or the part receive an equal portion. Equivalent fractions are those fractions where two or more fractions represent the same part of the whole. To get the fraction equivalent to the given fraction, we multiply and divide the numerator and denominator of the given fraction by the same non-zero number. A mixed fraction, that is equals to a whole number plus a fraction. The following rules are used to compare the fraction. Rule number 1. Among two fractions with the same denominator, the one with the greater numerator will be the greater. Rule number 2. Among the two fractions with the same numerator, the one with the smaller denominator will be the greater of the two. Rule number 3. Let A upon B and C upon D are two fractions. Then we cross multiply and find their product, A into D and C into B. If A into D is greater than B into C, then A upon B will be greater than C upon D. If A into D that is less than B into C, that means A upon B is less than C upon D. If A into D equals to B into C, that means A upon B and C upon D are equal. Sum of the like fraction, that is equals to sum of their numerator upon common denominator. Difference of like fraction, that is the difference of their numerator upon common denominator. For adding unlike fractions, change them into equivalent like fractions and then add. For subtracting unlike fraction, the same. First we have to change them into equivalent like fraction and then we will subtract. Clear? So here we end the chapter. I hope you understand the chapter well. Now you have to practice this chapter.